Good morning everyone. I am Tanushri from Civil Engineering branch, and today I am going to teach you your Theory 2 paper which name is Structural Design 2. So in the last class we will discuss about the various kinds of formula involved in bolting connection, like your strength of the bolt, strength of the plate and efficiency of the bolt. Okay, so today we will discuss some numericals regarding this bolted connection. Okay, so here one numerical on bolted connection. So the question is, design a lap joint to connect two each of width 100 mm if the thickness of one plate is 12 mm and the other is 10 mm. The joint has to transfer a working load of 100 kN. The plate are of Fe410 grade. Use bearing type of bolts and draw connection details. So here, what are the data givens? Your data givens are B equal to 100 and thickness of two plates are given as 12 mm and 10 mm. Another thing is working load is given at the joint which is 100 kN and the grade of the steel is given Fe410, and here grade of the bolt is not given. So we assume that the bolt grade is 4.6 and M16 bolt are used. So M16 means your diameter of the bolt is 16 mm. So due to the diameter of 16 mm, we have the bolt hole diameter 18 mm, by which we can identify the FUB value as 400 Newton per mm square. So now we have to calculate the strength of the joint, so that we have to find out the strength of the bolt and strength of the plate. So due to it is a lap joint, so that in this case your NN value is 1 and NS value is 0. So that while we calculating the nominal shearing strength, to find out the design shearing strength, here we put the value of NN as 1 and NS as 0. And to calculate the ANB and ASB, we put the formula as pi by 4 d square and 0.78 pi by 4 d square. So as usual, we put the formula here. Then we will get the value of nominal shear strength as 36218 Newton. You can convert this value as kilonewton also. So the design strength of bolt in shearing we calculate as the nominal strength in shearing divided by partial safety factor. So partial safety factor is denoted as gamma MB, which value is 1.25, which we will get from the table number 5 in IS 800-2007. So while we divide 36218 by 1.25, we will get 28974 Newton. So as in this question, your edge distance and pitch distance is not given, so we have to calculate this value from direct formula, which is already in code. So to calculate the pitch distance, we have to put the formula 2.5D. D means the diameter of the bolt, which is, we assume that 16 mm. So 2.5 into 16 equal to 40 mm. Like this, we have to calculate edge distance also, which is 1.5 D0. D0 means diameter of the bolt hole. For the 16 mm dia bolt, the D0 value is 18 mm. So 1.5 multiplied with 18 equal to 27 mm. And we will take the 27 mm as 30 mm. Okay. So now come to the nominal strength in bearing. So for that we have to calculate KB first, because your nominal strength of the bolt is given as 2.5 KB dt Fu. So Fu, T and D we know the values, but to calculate the KB we have to find out for another criteria, which is E by 3D0 and P by 3D0 minus 0.25, Fu, B by Fu and 1. So here directly the values are provided. So your E is 30 and 3D0 means 3 into diameter of the hole, which is 18. So by calculating these 4 criteria, the minimum of these 4 values is known as your KB value, which is 0.4907. So here we got the value of KB, which is 0.4907. So the nominal strength in bearing of the bolt is calculated as 2.5 KB dt Fu. So KB we got 0.4907, D is your 16 and T is the minimum of the thickness. So one thickness is your 10 and another thickness is your 12. So minimum is 10. So here we provide 10, then your Fu value is 400. So your value is 78512 Newton. Then the value of design strength in bearing you can calculate by dividing partial safety factor with the nominal bearing strength. Okay, that is 78512 divided by gamma MB, which is 1.25. Okay, so now to design the plate section, in question it is given that the working load, which is 100 kN. So to calculate the numbers of bolt, the formula is design load in joint divided by strength of the bolt. So the strength of the bolt is the minimum of strength in shearing and bearing. So in case of shearing, we got the value as 28974 Newton, and for the bearing case we got maximum value. So the minimum of these two strength is strength in shearing, which is 28974. So the strength of the bolt is also 28974 Newton. So to calculate the number of bolts, we should provide the design load at joint, which is 150 kilonewton. We convert it into Newton, okay, and divided by strength of the bolt, which is 28974, which equal to 5.18. So we will take this 5.18 as a round figure, that is 6 numbers of bolt. So here you can see the detailing of the plate section. Okay. Next one is to calculate the strength of the plate. So we know that the strength of the plate formula is TDN 0.9 ANFU divided by gamma ml. So here we know the value of Fu, we know the value of gamma ml, only we have to calculate the value of An. So An equal to B minus 2 into numbers of bolt in critical section multiply with thickness of the plate. So here you can see the critical section means in one vertical line how many numbers of bolts are there. So if we draw a vertical line over here, then in one single line 2 numbers of bolts are there. That is here also, that is here also, and here also. So in each vertical line 2 numbers of bolts are there. So the 2 is the numbers of bolt in critical section, and the total B is 100 mm. Another thing is D0 is your bolt hole diameter, which is 18 for 16 mm dia, and thickness of the plate is given as 10 mm, which is the thickness of the thinner plate, and Fu is your 410, and gamma ml is 1.25 in the code. So by calculating the whole formula, we will get 188928 Newton, which we will convert into kilonewton, that is 188.928 kilonewton. So your strength of the plate is always greater than the design strength of the or design load of the joint. So here you can see the design load is 150 kilonewton, which is present in the question, and we will get the strength of the plate is 188.928 kilonewton. So our section is safe. So this much is your first question, and it is a 10-mark question come in the semester. So today this much. We will discuss another problem in the next class. Thank you.